Okay, so we're going to talk about certain operations that we can perform with functions. Just like we could with numbers, we could add, subtract, divide, or multiply two functions together. There's a little bit of a different notation we use for this. So if we say f plus g of x, then that just means that we're adding the two functions together, f of x and g of x. Similarly, f minus g would mean that we are subtracting f of x by g of x. So this notation where it just says f times g of x just means multiply the two functions together. And same thing for divide. So let's practice. Given f of x equals x squared plus 5 and g of x equals 2x plus 5, we're going to find all four of these operations. So f plus g of x just means we're going to add the two functions together. So x squared plus 5 plus 2x plus 5. And if we combine like terms, that gives us x squared plus 2x plus 10. Okay, so if we calculate f minus g of x, so we have to be careful here because, so this is going to mean, of course, f of x minus g of x. But what we want to be careful about is we're subtracting the whole function g of x, not just the first part of it. So we'll write x squared plus 5, but I need to make sure that I subtract the entire quantity 2x plus 5. Rather than, if I didn't write the parentheses, I would only be subtracting 2x and then adding 5. So what that means is I'm going to distribute a negative 1 here, which gives me x squared plus 5 minus 2x minus 5. And then combining like terms gives us, so we have plus 5 and minus 5. So those subtract to 0, and we're just left with x squared minus 2x. Okay, so then for multiplying two functions, so if we do f times g of x, that means we're going to multiply x squared plus 5 by 2x plus 5. And you might remember from Algebra 1, this is a situation where we use the FOIL acronym for multiplying. So we multiply the first terms, so x squared times 2x gives me 2x to the third power. X squared times 5 is 5x squared. And then 5 times 2x is 10x. And 5 times 5 is 25. And now I have an x cubed, an x squared, a single x, and it's constant. So there's no like terms there to combine, so that's fully simplified. And then the last one is f divided by g of x. And this is going to be the easiest one. So f of x is the numerator, g of x is the denominator, but there's actually nothing I can do to simplify that further, so that's my final answer. Okay, so here we have a similar question. Using the graph, we're going to find these operations. So on the graph, we have to remember that the y values are, finding the y values is the same as finding f of an x value, right? So to find f plus g of 1, first of all, that means I'm going to find f of 1 plus g of 1. So let's go over to the graph. On the graph, it says the wave is g of x and the linear function is f of x. So f of 1, that means that when x is 1, I have a y value of negative 2. So this is telling me that f of 1 equals negative 2. Okay, so then I have negative 2 plus, and then if I go over here and I go to g of 1, I can see that g of 1 equals 1. So this is negative 2 plus 1, which I think equals negative 1. Okay, so let's do the same thing. Now we're finding f times g of 3. So that's going to be f of 3 times g of 3. So again, we go over to our graph, and we can see that g of 3 is negative 1, and f of 3 is 2. So then f of 3 times g of 3 would be the same as 2 times negative 1, which is negative 2. Okay, so a new operation we have here is called composition of functions. So composing two functions means that we're going to take one function and use it as the input to another function. And this is written as, notice this is an open circle, so f open circle g of x means we're composing two functions. And the other notation we have is, instead of writing f of x, we write f of, and we put an entire function here in the parentheses. So it's f of g of x. Okay, so here we have f of g of 1, or sometimes fog of 1. So what this means I need to find is f of g of 1. So I'm going to go, I need to work on the inside and then find the outside. So I can find what g of 1 is. Here I just have a list of points that tells me the values for the function g. So this tells me when x is 1, then g of 1 is 3. So f of g of 1, we know this thing is 3, so now I just have f of 3. And I can see from this pair here that f of 3 also equals 3. Okay, now the other example we have g of f of 1, or gof 1. So now I'm going to find g of f of 1. And what we'll see here is that these things, the order matters when you compose functions. So if we find f of 1 first, we can see that that is 2. F of 1 equals 2. So this is the same as finding g of 2. And here we can see that g of 2 is 2. So see how we got different answers for both of these. So composing functions isn't the same as like multiplying them. Even though the notation looks similar, composing, we're evaluating one function and then plugging that number into another function. So here we can do this also algebraically. So for f of x equals x plus 4 and g of x is x squared minus 7, we are going to find f of g of x and then g of f of x. So first let's do f open circle g. So that means I'm going to find f of g of x. So what I'm going to do, this highlighted part represents g of x. So instead of writing, and I want to plug this into x here. So instead of writing x plus 4, I'm going to write this entire thing plus 4. So that would be x squared minus 7 plus 4, which comes out to x squared minus 3. So that's f of g of x. And if we go in the other order, so g of f x, now that means I'm going to find g of f of x. So I'm going to do it in the other order. So now I'm going to go this way. Here's f of x. I'm going to plug that entire expression in to the x here. So now I'm going to have, instead of x squared minus 7, I have this entire quantity squared minus 7. Now, some of you might be thinking x plus 4 squared would be the same as x squared plus 16, but those of you are wrong. Because what does it mean to square a number? When we square something, we multiply it by itself. So if we're squaring x plus 4, then we have to write out x plus 4 times x plus 4. And that's going to be a, and then there's the minus 7. So that's what it means to square x plus 4. Now I'll use my FOIL method to multiply these together, and I get x squared plus 4x plus another 4x plus 16 minus 7. And when we combine our like terms here, we get x squared plus 8x. 16 minus 7, I think, is 9. So plus 9. Okay, the last example we have here is, now we're finding f of g of 6, or f of g of 6 given these two functions. So notice these functions are a little bit weird looking. We have an absolute value function and a square root function with some squared going on inside. But we're just going to be evaluating the number, so we don't have to find the actual function of x that describes f of g of x. We just need to substitute 6 in. So we're first finding f of g of 6. And that means that I'm first going to find g of 6. So g of 6 equals the absolute value of 6 minus 8. And the absolute value of, so that gives me absolute value of negative 2. And you forgot what absolute value is. The most formal definition is that an absolute value of a number is the number of spaces from 0. So when we talk about the number of spaces, that always has to be positive. So the absolute value of a negative is always a positive. The absolute value of a positive would also be positive. So the absolute value of negative 2 is 2. So now that we found g of 6, we're going to find, because we wanted f of g of 6. So finding f of g of 6 is now the same as finding f of 2. And to do that, we'll plug 2 in. So now we have the square root of 2 squared plus 6 times 2. So notice I plug 2 in to both places that x appeared. Okay, so then that's the square root of 4 plus 12, which would be the square root of 16, which is 4. The end.